will be your last test of the semester. Thursday, we'll have another review day, but it'll be kind of like a semester review. Because then Friday, we kick off our retakes. There's 3 retakes. What's successful in getting them all to be multiple choice. Kind of the same that we do for term. If you choose which one you want to take, it'll be 4, 5, and 6. I have a meeting today again, but from the last we discussed it, it'll probably be 4 and 5 on Friday, and then 6 on the following Monday. You guys test the very next day on Tuesday, like the next week, like the last week, and then Saturday I won't see you again until next year. I won't see you the last 3 days of Any questions on that? Okay, all right, so these are the ones that missed the most. You got a copy of each one. We'll just go through all of them. Identify holes and vertical asymptotes of each. What do holes and vertical asymptotes have in common? Okay, they do both come from the denominator, but yeah, what simple word can be used to describe both of them? Yeah, they're both types of discontinuities, and they both come from the denominator. The only thing with the holes, if you're going to have any, I guess you could even argue for both of them. In order to differentiate between the two of them, you also have to factor the numerator. And in this one here, each polynomial, there's more than one step factor required. They both have a GCF. In order to completely factor, yeah, now you could get away with it on the bottom, I guess, but if you don't fully factor, you won't be able to accurately compare polynomials. So on the top, what's my GCF? What do they both have in common? Yeah, they both, all 3 have an X. So it becomes X squared minus 5X plus 6. What 2 numbers multiply to give you -5? Sorry, multiply to give you 6 and add up to -5. Yeah, so X minus 2 and X minus 3. If these don't end up canceling out with anything in the denominator, what would each of those factors lead to? Okay, now let's look at the denominator. That also has the greatest common factor. What is it? What is a 4? But the thing is, if you don't also factor the negative, you're going to have a disaster when it comes to factoring. You don't want a negative lead when it comes to factoring. So we will make the 4 negative. If I do that, that will be x squared minus 2x minus 3. What 2 numbers multiply to give you -3 and add up to +2? -3 and +1. X minus 3. So if I just get these 2 fully factored polynomials and compare them, are there any common factors here? X minus 3. Now, even before that, here we go. Let's even go back. How many total discontinuities am I going to have? This is just listing. This is part of not math. I guess you can say maybe the math involved here is counting. You have to know how to do counting. How many total discontinuities are we going to have? 1. No. 2. Discontinuities come in the denominator, and there are 2 factors in the denominator that contain a variable. So those 2 factors are where they're going to lead to discontinuities, because both holes and vertical asymptotes are both types of discontinuities. Okay. This x minus 3 is going to lead to a discontinuity. This graph will not be defined when I have an input of x equals 3. When x is 3, I'm going to get a hair. This is going to lead to the function not being defined when x is -1. Those are both types of discontinuities. No matter how hard the -4 tries, the -4 will never become a 0. So there's no issue with the -4. There are 2 types of discontinuity, or the 2 total discontinuities. Now I got to figure out which type they are. That just comes as to whether those factors cancel or not. Because the x minus 3 cancels, the discontinuity that comes from x minus 3, which is the 3 vector, What type is that going to be? That's going to be a whole. This particular one happens to be multiple choice. It's not asking you about the why, because holes do have whys that go with it. If it were to ask you about the why, what would you have to do to find the why? Plug in the 3. Now you have to do it after you remove those x minus 3s. Because if you plug it in with the x minus 3 still there, that's what discontinuity is caused by. You get an error. But if you remove the x minus 3 and then plug in a 3, you get the y. Because the x plus 1 does not cancel, what type of discontinuity is a negative 1 going to be? Vertical axis. And again, as in, well, we never had a practice test on 5 because of the performance exam. I couldn't give you a practice test on test 5. But on the other 4 practice tests you've had this year, just like all those, these are the same. If you're actually listening and writing things down. Which answer choice is this? Holes in vertical asymptotes. But part of the reason why assuming you actually tried, and I don't know, passing back some of these papers, I don't know how hard some of you tried, but assuming you guys, like all you have to really do here is just try it, right? So the purpose of these is to identify what we struggle with the most. So assuming you tried, if I start seeing a bunch of these holes in vertical asymptotes, that means hey, I need to focus on holes in vertical asymptotes. I need to focus on discontinuity. So that's the purpose of giving you practice test. Again. Factor in just like on the first one. So both of these can be factored more than once. How do we factor the top polynomial? There's a GCF of x first, and then that leaves us x squared plus x minus 8. Where 2 numbers multiply to give me negative 8 and add up to the positive 2. So it's x plus 4, x plus 2. I know that this one might be a little tricky because you're like, boy, wait, 2 terms, I don't get it. But there's the greatest common factor there. Yeah, again, negative 4, just like the one before. And then once I bring up that negative 4, something magically appears that wasn't there before. Difference of squares. I told you from the time we started, hey, one of the, traditionally speaking, some of the worst units or the most difficult ones in algebra 2 are the rationals. That's 5 dealt with rational expressions and equations. Now test 6 is going to deal with rational functions. Why do we struggle with rationals? Because it involves the 2 equal f's in math, which are fractions. Fractions, yeah, because back with like expressions, you have to know the rules for adding fractions and when to do LCD and when to cancel common factors. And then what's the other one? Yeah, that's the big one here. If you're struggling with this, more than likely it's not because of anything new. You never had a very good grasp on factoring. Which is what we done. You do it on the one book also started. How many total discontinuities am I going to have here? Discontinuities come from the denominator. How many factors in the denominator contain a variable? 2. This graph will lack definition. It will not be defined when this is 0 and when that is 0. Now, at this point, I've stopped doing the, oh, hey, if x plus 3 equals 0, and then solve, I'm assuming that you just kind of get the hint, like that you can at least do it mentally. This will not be defined. X cannot be negative 3. Then x cannot be positive 3, because if it were, we would get an error. I gotta see what type of error. That depends if it has something to cancel out with on the numerator. Do we have any factors that would cancel out the numerator? No, therefore both of these are going to be vertical asymptotes. What's the answer choice? Is it B? Yeah, there's no holes. Bonus question, bonus question. Look, it's not even here, but why not? We might as well. If I were to graph this, would it cross the x-axis? Of course it would. Not only would it cross the x-axis, how many times would it cross the x-axis? No. 3 times. It would cross the x-axis a total of 3 times. When would it cross the x-axis? First at 0, then at -4, and then at x-intercepts. If discontinuities come from the bottom, x-intercepts gotta be come from the top, and it will come from any factor that survives being canceled. Get canceled. Because here looks like no, well maybe on no, yeah, just one step. Just one step. I can factor the numerator. Factor out a negative 2x. X minus 1. Correct? Then -2, -1. +2. And in the denominator, all we can do is factor out x. The reason why I like this one though, because of those ones and the signs. How many total discontinuities am I going to have here? I'm going to have 2. Look at the denominator, there's 2 possible ways that denominator could end up being 0. But if you mess up with the signs, you're going to think that second one is a whole. Maybe you mess up and you get 2 different x plus 1s, and you're going to think it's a whole. But it isn't. Now, is there a whole?
Yes.
Of course, yeah, look at the x's. Both of them have x's on the outside. So there's 2 total discontinuities, one when x is 0 and one when x is -1. The one with a 0 would be a whole. If I wanted to find the y that went with that whole, what would I have to do? Plug in the 0. Okay, just for fun, let's do it. This one's pretty simple to do mentally. If I were, you have to take those x's out because now you get an error. What's 0 minus 1? -1, right? What's 0 plus 1? But on the top, you still have to multiply by the -2. So -2 times -1 is +2, divided by 1 is 2. If they were to ask you, we would have what we want, 0. That's figure out on the y-axis. But this -1, even though you might be tempted to, those do not cancel out. Those are not the same. So we're going to have a vertical asymptote at -1. That is that B? These should have been, so the test had 25 problems, the practice test had 25 problems, Laura, and there was one that had a lot, well, I guess for you it was trouble. For me it was the last one, but for you guys it was kind of showing up anywhere. It was that true or false, I had made multiple ones, but like some of these were like this one, it should have taken you maybe 10 seconds. You get 2 polynomials, both in standard form. In order to find horizontal asymptote, that's great. I don't need to factor. I want it in standard form. How do I find horizontal asymptote? No, you don't look at the mean. What do you look at? You look at the degrees. You compare the degrees. On the top, I have a 3rd degree. On the bottom, I have a 2nd degree. The rest just comes from memorization. And memorization comes from study. When the bigger degree is on top, huh? There is no horizontal asymptote. Okay. Now here's something I'm going to do for you, because on the test on Wednesday it will ask you about slants. I believe I did have some questions here about slants, but you know what? It's not something we focused a lot on, and I'm going to have a ton of questions about slants. Let's just take an opportunity. Because this top degree is exactly 1 bigger than the bottom. 3 is 1 bigger than 2. 3 minus 2 is 1. There should be a slant asymptote. The only way you can have a slant asymptote is if you don't have a horizontal. It's possible you don't have any. But if that top degree is exactly 1 bigger than the bottom, you have a slant. How would you figure out the equation for a slant? Because the slant asymptote is slanted. diagonal. It's gonna have a y-intercept. It's gonna have a slope. What you would divide. Let's see if we're gonna divide this one here, and then this being third degree, I have more numbers, so don't forget you have to put the 0 at the end. This question is not asking me about slant. It's just completely for your information. I know you woke up this morning, and some of you actually haven't woken up this morning, but those of you that have woken up this morning were dying to know about slant asymptotes. Ask and ye shall receive. So let's start off dividing. What is x to the third divided by negative 4x squared? 1 is x divided by negative 4xx. Good, negative 1/4 x. Now there is good news for you. I know that there was a concerted effort amongst the people that took the questions for this test that you shouldn't have, like if you have to find a slant asymptote, those coefficients are going to be nice for you. You didn't get that from me. Now when you distribute, the nice thing is, these, when you multiply them in the first one, it should give you whatever's here. If not, there's no point of it. That's the whole point of it. Those are supposed to cancel out. What's negative 1/4 times negative 8?
2.
It is positive 2. Yeah. We're going to positive 2 x squared. Negative 1/4 times 12. Negative 3 x. So then we got to change the signs. This becomes minus. This becomes minus. This becomes plus. So we get negative 5x squared minus x and plus 0. But who cares? Because really, the only thing that's going to matter now, because everything else is going to lead to a remainder. But when it comes to slant asymptotes, you exclude you ignore the remainder. And all I got to worry about is what is negative 5x squared divided by negative 4x squared? So that the negative 5 goes on top. What's negative 5 over negative 4?
5/4.
Yeah, plus 5. If you were to be asked about the equation of a slant asymptote here, I don't care about anything else in the remainder. Negative 1 over 4x plus 5 over 4. What's the slope of that slant asymptote? Negative 1/4. What is the y-intercept? 1.25. Just a little bit above. Right, Randy? Randy is Randy. Curious to see that down agree. Same thing, horizontal asymptote, both are in standard form. This takes about 10 seconds. We compare degrees. Tommy, when you compare these 2 degrees, what can you tell me about those 2 degrees? They are the same. So therefore, is there going to be a horizontal asymptote?
Yes.
Yes. And where will that horizontal asymptote be at? You divide the lead coefficients, which on the front of the top there's a 1 and a negative 4. And remember, these are the ones missed the most. We had a total of, there were 28, if you include the true or false, I had 4 of them. There were 28 different questions you could get points from. I'm about to give you a little bit over half, 15 of them. And so these were all in the worst half. And I would argue that last year should have been one of these. Maybe they are. Maybe it was just too many people guessing. I just didn't care. We blew it off. We guessed. How about this one? Again, horizontal asymptote. The past 3 have been horizontal asymptote questions. We should pray that we have as many horizontal asymptote questions as possible on test on Monday. Can't get easier than that, especially if they're already giving this to you in standard form. Which degree is bigger? The denominator, when the denominator has a bigger degree, it's just always going to be y equals 2. Study session tonight, Randy's house. I'm gonna be there. Okay, let f of x be whatever's there, which of the following is an equation of an asymptote. Okay, so this is, I like this question. So now this doesn't say anything about what type of asymptote. We just gotta figure out which one of these would be an asymptote. So let's do the easy one first. Okay, horizontal asymptotes. Both of the polynomials are in standard form. That negative out in front doesn't really mean anything. It just the only thing that negative would come into play is if you end up having to divide the leads, and just attach it to the two. And then actually, well, I think of that, I guess in this case it does play a role because when you compare the degrees, which degree is bigger? They are the same, so you do have to divide the leads. What is negative 2 divided by 1? Now, the other thing you have to understand, this is about also basic algebra 1. Any horizontal line, whether it's a real line, an asymptote, whatever it is, any horizontal line on the graph starts off with y equals. This would be y equals negative 2. That's what we have a horizontal asymptote. Okay? Now, in order to find vertical asymptotes, you have to factor. You can't factor the numerator. Okay, for the numerator, that would just stay the same. But in the denominator, two numbers that multiply give you negative 4, negative constant 3, or plus 4, or minus 1. Neither of those cancel out with anything in the numerator, so therefore we're going to have two vertical asymptotes. We're going to have one that x is equal to negative 4, and that x is equal to 1. So we're going to be so which of, anytime you have a vertical, it starts off with x equals. Which of those are listed up there? Yep, x equals 1. None of those other ones are there. If you didn't understand the difference between what constitutes a horizontal and vertical line, if you don't know that horizontal lines start off with y equals and vertical lines start off with x equals, what might have you been tempted to pick? Yeah, D or E, sure. But those are the same numbers, but just different variables. How about if you maybe messed up with factoring? What might you have been tempted to pick? C, sure, because maybe you with the signs. And then if you still don't know where the discontinuities come from, maybe you would have picked. I don't know why you wouldn't pick it with a Y. Well, I guess maybe I guess this was there as a distraction from horizontal, maybe. Maybe some kids tend to think that all horizontal asymptotes are always going to be attached. Which types of asymptotes appear here? So this was just, you don't have to actually find where they're located, but which ones appear. All right. Well, if there's going to be a horizontal asymptote, you'd want to see it in standard form ideally, which both of these are. You would compare the degrees, and remember that these two go hand in hand. Is there a horizontal asymptote there? The top degree is bigger, so we are not going to have a horizontal. But because the top degree is exactly one bigger than the bottom degree, there would be a slant. Notice how this also says select all that apply. So there could also be a vertical. And I can see that I will have a discontinuity. I don't know yet if it's going to be what vertical asymptote or not, but I know that x can't be negative 5. Does that cancel with anything in the numerator? So it's not a whole, it would be a vertical asymptote. Which of the following functions has no vertical asymptote? All right, this just saves time. But A is already factored, damn, that cancels out. B, even if I were to factor, in order, okay. For A, even though the x minus 7 cancels out, this is still going to be a vertical asymptote. For B, yeah, go ahead and factor it if you want, but like nothing's going to cancel with the x. Like there's no x to pull out here. So any discontinuities that come from here would have to be vertical asymptotes. So it can't be that. Here on C, there's nothing to cancel out with that x minus 2. Like I'm going to have a vertical asymptote of 2 because it can't be a whole. It's going to cancel out with it. So I would think like, a lot of you were tempted to pick E, but if you look at D, the denominator is already factored, and if you factor the numerator, you also get x minus 4, x minus 5. There are two discontinuities, but because they are both removable, what types of discontinuities are those? Yeah, they're both poles. So which one of these has no vertical asymptote? Have questions, say something. Which of the following fractions has a whole at 1/4? Okay, there's the next one. So we have to have a whole, and it would have to be at 1/4. Okay, I know it can't be C, just because C doesn't even have a whole. In order to have a whole, you have to have factors that cancel. Okay. Now, both A and B both do have wholes where the x is going to be 1. X minus 1 squared is the same thing as saying x minus 1, x minus 1. So it would, like, they are going to have holes at 1. But when I plug that 1 back in, for this top one, I'd have a 1 on top. When the entire numerator cancels, I have a 1 on top and a 1 minus 5 on the bottom. That gives me 1 over -4. That's not the same thing as 4. On this other one, I again have a 1 on top. I have an x minus 1 on the bottom, which is 1 minus 1, which is 0. So it's actually going to be, it's not even going to be a whole, it's just going to be a vertical asymptote. If you have a whole and a vertical asymptote at the same spot, the vertical asymptote is not going to be defined anywhere there. But now when I go to this other one, once I remove the 1, because this also is going to have a whole when x is equal to 1, if I plug the 1 into what's left over, it'd be 11 times 1 plus 1. The top would give you 12, the bottom would give you 3, and you look at that. Again, in order to find the y of the whole, you remove the discontinuity and then plug in whatever x the whole is at. What are the asymptotes of this the graph? Okay. So again, it doesn't really tell you what type of. I mean, you can look at the multiple choice and see what's there, but it doesn't really tell you what type of asymptotes to look for. Now remember that the only way you can have a slant is if you don't have a horizontal. It's only one or the other. But let's start off with horizontal because those are easy, I guess. Am I gonna have a horizontal there? Yes. Why? Okay. Or you can say the bigger degree on the bottom, sure. So anytime the degree on the bottom is bigger, where's the horizontal asymptote gonna be at? So I start saying 100 to 1 equals 0. If I have any type of horizontal asymptote, I cannot have a slant. Hold on, let's see. I don't care about multiple choice. I want to find them on my own, and then I'll just compare and contrast afterwards. Then for vertical asymptotes, we have to factor. I can't factor the numerator, but the denominator does become x plus 1 and x plus 2. And I can tell none of those cancel. So I'm going to have vertical asymptotes at x is -1 and at x is -2. So which one of those say that? Did any of you guys check their school emails at all? Because I also sent the results of this to your school email. I've tried doing it before with other emails, but it won't have it. So like, you could actually see a copy of what you submitted if you check it on the piece. Remember, there's no black person. A rational function is graphed below. Which of the following is that? All right. Chicken and the egg here. Okay. The graph and the function. If they were to give you just one function and ask you to graph, then I would do so. I would graph. I would find my asymptotes, I find holes, I find intercepts, I find everything that I learned about, use my test points, and graph the way we did, on a bunch of basically that packet I gave you last week. That's almost all we do is graph. But it's backwards. Here, they're giving you the graph, and then they're asking you to pick a function. So really, yeah, look, the way that this is, when it's tailored like this, you're kind of relying on the whole. We're not going to come up with a function from scratch. Okay, we're going to just compare and see which of these best fits, basically. All right. So let's see what I'm looking at. Based on what I'm looking at, I can tell I see a vertical asymptote here at -1, and it appears we have another one at +1. So I'm looking for something that on the bottom has an x plus 1 and an x minus 1. And I should be able to see that. I can also tell by the end behavior, by where those arrows are pointing, that there's some type of slant asymptote. Now, since slant asymptotes can be crossed, it's going to be hard to come up with the equation unless they actually show me it. It's hard to come up with the equation, but the thing is to know that it exists. And if a slant asymptote exists, what does that mean? Not only should be a higher degree, but yeah, that the numerator needs to be exactly 1 degree higher. All right. So like whatever the degree is, like this needs to be +1 up here. Like right now, I have a 2nd degree. I would expect to at least see a 3rd degree up there. The only other thing I see, I see 2 other things, is that it looks like, even though it's kind of hard because it's a vertex, but it looks like this is also crossing the x-axis at 0. So you would expect to see an x up here, and I'm also crossing the x-axis. It looks pretty close to +2, so I would expect to see an x minus 2 up there. Okay. If I have a slant, I know I can't have a horizontal. So that's based on what I know how to find, like all the clues I know, that's what I know. So I'm just expecting to see some other factor. Maybe it would probably have to, even though I don't see a hole here, I guess it would have to match one of these maybe, in order, because if I had a different factor up here, it'd have to cross the x-axis. Oh, you know what? One of these could be squared also. One of these could be a repeated factor. That could be it. That either the x or the x minus 2 has an extra degree on it. So let's see. Let's look at, well, it looks pretty good, doesn't it? Already, right off the bat. What's the degree on top? Yeah, because this is squared and 1, which is 3, on the bottom is 2. So A looks like a really good one already, because it kind of looks like what we constructed. So let's just check the rest of these, see if we can eliminate them. Hey, why is B no good? Yeah, it would have to have a horizontal because the degrees are the same. It can't be that. How about C?
This would be x-intercept and the degrees of the same.
Say that again?
It's missing the x-intercept.
It's missing an x-intercept, sure, and the degrees are the same, sure, no good. How about the last one? The degrees work out. Is that what it is? The asymptote? Yeah, because the asymptote is supposed to be a 1 and -1. Yeah, that's not a vertical asymptote. So actually, that would be a hole there. Yeah, can't be. And again, they give you a graph. They like we're gonna have to rely on the multiple choice here. Like we're not gonna be able to come up with it entirely on our own, but we can take a look at the graph, see what we know about it, and then pick which one best fits. Now this one does appear to have a horizontal asymptote. You can tell by this is flattening out as it goes on to infinity. It appears to have a horizontal asymptote, and where is that horizontal asymptote located? Yeah, at y equals 0. So what we're expecting there is to have a bigger degree on the bottom. The bottom degree should be bigger. Even though here we are crossing the x-axis, or like horizontal asymptotes can be reached. They can be crossed, and if they do, it usually happens in the middle. Not always, but usually. I can't tell for sure where that's crossing, but it looks like to be crossing at -1. So I can expect to see like an x+1 up here. We are touching the x-axis. Looks like somewhere around there. How about vertical asymptotes? It appears we have a vertical asymptote at what, -3, so I would see +3 up here, and another one here at 1, so we would see that's -1. We did intercepts. The y-intercept, and there is a y-intercept, but it looks like it's underneath the 0. Doesn't look like it's at 0. It's hard to read. Like I can't even tell if this is crossing here at -1, or maybe it is even crossing at 0 and it's just the origin. At this point, yeah, let's just start taking a look and see what we can eliminate. Okay. I guess let's look at the. Let's see what we can eliminate first. A, I can't, even though it looks like you might be able to eliminate it. I'm looking at the degrees first. The bottom degree is bigger, so let's hold on to A for a second. How about B? They're the same, so I know for sure it can't be B. How about C? The top degree is bigger, can't be C. So it looks like as far as degrees go, we're stuck somewhere between A and D. Okay. Now the difference is that A touches the x-axis. Actually, no, I'm sorry, it can't be D. No, it can't be D. Yeah, the degrees are the same. So therefore, it can only be A. That's the only one it can be. And look at that, the degrees were enough. Now you might say, whoa, but slow down there, Mr. Romero. You said that we were supposed to have a vertical asymptote at -3, and that doesn't say x+3. Well, yeah, watch this magic. If 3x plus 9 were to be equal to 0, what do you get for x? Yeah, -3, so you still have a vertical asymptote. That's kind of why when they give it to you in this form, or they're giving you the graph, you kind of have to rely on the multiple choice. There's no way to be able to just exactly know. Okay, which equation correctly describes this? Ooh, here you go. Here's a slant asymptote question. Okay, they're already telling you the slant. This will be kind of what it looks like on the test. So most people want to pay attention. We're going to have to divide like we did earlier today. X squared plus x. plus 0, because you have to, if there is you need a placeholder. X to the third minus 2x squared minus 8x. Now this is kind of telling you if on the test you're much more likely to have something that works out nicely with your coefficients. X to the third divided by x squared is just x. When you multiply everything times x here, you get x to the third plus x squared plus 0. This becomes a minus, this becomes a minus, and this one doesn't even matter because it's a 0. So this cancels. Here we get negative 3x squared here in the second space drops. And then what is negative 3x squared divided by x squared? No, negative 3 divided by that one. It's just negative 3. So our slant asymptote, we don't care about the remainder. Anything that would come after that will be the remainder. Just x minus 3. Questions? Okay, and then finally the last one, so we'll be able to get to it today. Is this true or false? Determine whether each statement is true or false. See, so maybe the format might have gotten you here. Was anybody under the impression that these were both the same function? Because I mean, it pretty clearly says here, look, this is function f, this is function p. So this is not a graph of this. Those are two completely different functions. Just one of them they're showing you a picture of it, on the other one they're showing you the function itself. Caitlin, which one do you like better, the equation or the graph? So do both functions have a vertical asymptote at x is equal to -2? Well, I can tell the picture does. That's pretty obvious. I mean, you can tell just by looking at it there. Here, -2 have a vertical asymptote. We got to check the other one. How would we figure out if we have an asymptote there? Factor the denominator. Question is not anyway, so let's put it on the bottom. This is x minus 3x plus 3. Do we have an asymptote at -2 there? Yes, we do, for that second factor. This is going to have, actually, it's going to have 2 asymptotes. 4x plus 3 there, so we're going to have a vertical asymptote at 3, and a vertical asymptote at 4. So this first one, here, even that's the moment. Well, I'm actually doing more than 15. I'm doing 18 out of 28 we're being assessed on. You come up with the extra 10. Remember, just like I don't know if you're gonna walk through the practice test. If you, as long as you took the test the first time, you got 2 shots of it. You take the retake twice, but if you weren't here and you didn't take it on Friday, you don't go twice. The horizontal asymptote for g of x is 1 less than for f of x. Okay? So for g of x, this horizontal asymptote is at y equals 1. For f of x, where's my horizontal asymptote going to be at? 1. The bottom degree is bigger, therefore, y equals 0. When the bottom degree is bigger, doesn't matter what's in front. Bottom degree bigger, always on top of the x-axis. Doesn't matter what you have, what has your lead coefficient. So is g of x 1 less than f of x? No, g of x is 1 more than f of x. So, false. See, both functions have an x-intercept at -3, 0. Well, on the graph, it should be easy enough to check, and it is. We do have an x-intercept there, how would we check on this other one? What do x-intercepts come from our function? And I do have an x-intercept there at -3. So both of these do. Now this last one here, I did not really like the wording of this. This was written by the same source that will write your test on Wednesday, so that's why I left it in. I was thinking about just erasing part B, but I left it in just in case. There's a hole when x is -3 for f of x, but x equals 3 for g of x. And this is what I had to biggest beef with. When they say x equals 3 for g of x, that means an x-intercept. Actually, even that's the way I read it before, but who knows? Like that could even be a hole there too, the way it's worded. At the time I made this, I hadn't seen the test. I have seen the test afterwards. Again, I left it in there because I wasn't sure if you would see the test. It could be an excess, it could be a hole. Let's go look at g of x and let's see what's happening at 3. What do we have as 3 there? Here we have a hole. There's a hole when the reason why I think it's an x-intercept is because of the use of this word here, but. When I say but, that means that they wouldn't be talking about a hole, that they'd be talking about something else. On f of, how about on f of x? Here's where you would know. Does f of x have any holes? No. So, I mean, that would be where you would look at. There is no hole on f of x. F of x has no hole. Even if I'm already confused you. Are there any other questions for me? Alright, so listen carefully then. Hopefully, hopefully I'm here tomorrow. Assuming that I am here tomorrow, we'll just finish up. Hold on, please. Assuming that I am here tomorrow, we'll just finish the packet. Make sure you bring the packet with you. But if for some reason I have to miss, and I'll let you know, if I do end up having to miss, I'll send you a reminder. Everybody should be on a reminder already anyways. I'll try to see if I can put on YouTube like the same way I post my lessons. I would put it under Tuesdays for tomorrow, because that would be tomorrow's lesson. I would post me going over those last few problems on packet. Every week I have a subsection that says videos. Week 17 videos. On the packet, I can get. Do you have the packet for the notes? This may be the last 3 or 4 slides that I didn't get. It's not a lot. Yeah, the one that says week 17. So I'd have to go back and check the videos, but I'm probably missing about the last, I don't think any more than 6 pages, maybe 5 or 6 pages.